Hello, this is Juan Blanco from Ethereum. I'm going to take you through the simple steps of creating a smart contract and then use Ethereum to deploy it to a private chain, and later on do a small call to the contract to verify it's working. As I said, the steps that we're gonna follow are first create the contract, then compile the contract, let's get the bytecode and the API, then using Nethereum, Visual Studio, we will be unlocking our account. Okay, before this, obviously we will need to start get and run our private chain, and then we'll be using Ethereum, unlock our account, deploy the contract, and mine the transaction of the deployment, and get the receipt for that transaction, which will contain the contract address, and finally do a simple call. The contract that we're gonna create is will be a very simple one, so will be the multiplication contract, a little bit more flavored, so we will have a specific parameters, the constructor. So when we do the function call, it will be just called multiply. So that's the plan. So first of all, let's create the contract. I have a environment already set up here, so if I open the contracts folder using Visual Studio Code, I've already have here our test.sol to create our smart contract. In Visual Studio Code, you have the Solidity extension, which you can find by pressing F1 and EXT, and you can install extensions, or you can install a new one. So for example, you can search for Solidity here, and there you go. Once you go install, you can start creating your own contract. This one is called test. Like I said, this is a very simple multiplication contract. So let's do a simple function here, which it will multiply, and we're gonna pass a value, and it's going to return another int. Okay, so what we could do is just return here about multiply by 7, and we'll be up and running. Just to make it more interested, instead of hard coding here the value, we're going to pass it in the constructor. The constructor is the same name as the contract, and that's how it's defined. And found. So if we can pass here a multiplier, we can then assign it to our contract scope variable. And if we multiply now by the multiplier, we have our simple contract finished. So let's F1 and compile, and yeah, we got this small error here. And let's try again. We got any more errors? And yeah, that's the problem. Variable. And yeah, that's done now. Let's clear the errors. And it has output here the contract bytecode, the compilation, the compile contract, and your ABI. The ABI is the whistle, if you're familiar with the web service of a contract. It's mainly here describes the functions that you have, the inputs and outputs, and also here the constructor. More complex contracts will have also listed the events associated with them. So this is it. We have created a smart contract. So right, the next step, let's see. Let's start get and run our private chain. In Ethereum, I've created a small folder. If you pull up the whole code, you can find it also here. Second, in here. So you can simply just run your own private test chain. This is a small batch file, which every time you run it, it will clear all your chain data information. So it will start from scratch, but leaving an account with enough ether for you to work. So it's very useful for unit tests that you can just launch your small test chain and your account will remain the same. So the only work that you have to do is just put get in here. So we start the chain, and if we have another one running, it won't work. So let's start again. As they share the same, they listen the same port, and that's it. We got our private test up and running. So we head now to Visual Studio. I've already prepared a project which it's got the only dependency that you need is Ethereum Web3, and then will if you add it as a NuGet, it will pull down all the other dependencies. You can also use Ethereum Portable. Obviously, as part of this project, as I'm using XUnit, XUnit is included. Just a quick overview of NuGet. So just type Nethereum. Yeah, so good. Obviously, you can see all the other packages, but this the top high level is Nethereum Web3. So let's start coding. Okay, so we started our test chain, but we will need some account information to so I have already here the account that I use for testing and the password. The next step will be to unlock this account so we can send the transaction. So let's try to, for this will we create an instance of Web3. Web3 is just mainly like the top level layer to be able to interact with an Ethereum client by using RPC. And the default settings for this it's the default RPC configuration for Ethereum, which is 8545. So we don't really need to do anything. You can also pass your custom RPC client if you wish to. Now let's unlock the account. So here we will use the Web3 personal, where you have the options to unlock list accounts, lock account, new account, and the sign and send transaction. This is very useful. It was introduced lately, so you can in one request send the transaction, unlock it, and then close it down again, so you don't leave the your account unlocked for a period of time, which is can be prone to attacks. But this is a scenario where you're just gonna unlock it. So let's pass the sender address, put the password, and how long we're going to unlock it for. And now we'll put a couple of minutes, which would be far too long, and probably we could get away with 5 seconds or a couple of seconds, really. Not even so. So then, yeah, okay, so we have unlocked account. I just verified quickly for our unit test that the account has been unlocked correctly, and the next step is to deploy it. So the deployment will return as a transaction hash, and well, yet again we'll use Web3, but this time we'll use Eth. In the Eth environment, such this is where you are able to find all the Eth related functions, and which can be obviously the deploy contract or get codify contract, and in the transactions area there are many other functions as well, and so on. But now we just interested in deploy that contract, so let's deploy it. Let's pass the ABI. So haven't declared the ABI yet. Because we are deploying using a contract with a constructor, we need to pass the ABI. This shouldn't be necessary if our contract did not have a constructor. Just to apply a small formatting of the ABI itself. It has semicolons, and obviously we need double semicolons. So okay, we got the ABI, and now we are going to need the bytecode, which is the compile code. Similar way, just copy the code, the compile code, bytecode, and let's declare it in a variable. Prefix it with 0x hexadecimal, and let's pass the bytecode now, and our sender address. We don't really need any to worry about gas at the moment because it's a very simple contract, but we need a parameter, so let's pass the multiplier. We put 7, so our target could be to multiply 7 by 7. So let's pass the multiplier there, which will be encoded correctly to interact with Ethereum. Okay, so we have the transaction hash now, but the transaction has been put in the queue until it's fully verified by the consensus. In this scenario, we'll be the only ones who will be providing the consensus. If you were deploying this to test the public testnet like more than or live, you wouldn't require to mine it, as there are plenty miners there. But because it's a private chain, we need to mine it. So let's mine. And for this we will use Web3 now miner, and we'll start it. Send the request async. We send request async because we communicate through RPC. Just put the number 3 to 6 so it mines faster. Now we just verify the result. Okay, so we have unlocked, we have deployed the contract, and now we mine him. And now we need the receipt of the transaction that will contain the contract address so we can interact with it. So let's get the receipt. This will be in the transactions area. Get transaction receipt, send request async, and we pass the transaction hash, and that's it. What it can happen is that the transaction has not been mined yet. If the transaction has not been mined yet, our receipt will be null. So we need to verify if it's null, and then give it a bit more time to be mined. So we can just sleep for a while and just give 5 seconds as it blocks. It's around 15 seconds between blocks. So I don't know the current figure at the moment. Depends of the test chain and so on. So let's try to get the receipt again, and that's it. Okay, so we're waiting here. So now let's get the contract address. We can get it from the receipt, and from the receipt you can get all the information, the block hash, the block number that was mine, and so on. I want the contract address. This is a special one for when we deploy a contract. Now that we have the contract address, let's do some. Let's have some fun with the contract. Just do a simple call, and we can get the. First, we need to get a contract, and we can use add for this. This is just a function to get a contract wrapper to make it much easier to interact with the contract. And so, for example, we can now get the function itself. So let's get the multiply function. And now that I have the multiply function, what it does is using the ABI, it finds the function called multiply, which is in here, and then obviously now it's got information of all the inputs, outputs, and how to encode it and decode it, and so on. So now we got the function itself. We can call a method. So let's see what will be the result of calling multiply. Obviously we're expecting an int as the output, as you can see it, it's an int there. Obviously we know the contract itself, so let's put 7 again. So multiply 7 by 7, we will expect a result of 49. So let's see if that's true. One thing to note is when we're doing a call, this is not a real transaction. The difference between a call and a transaction: a call is something that you execute in the blockchain without any verification. So you can just call and get data, or call and do this multiply operation that it does not in any way requires any consensus by the rest of the chain. When you submit a transaction, that's completely different. You won't have a result. You will just submit the transaction, and it will be verified by the whole participants and the nodes in the chain. So okay, so now we've got the full program with the full test, and let's run it. Let's debug it so we can go through all the steps and review what we've done. And once the debugger starts, let's look at what we've done with the code itself. So we started Visual Studio Code. There you have other IDEs. Let's just use Visual Studio Code because I like it. But this is the extension for Visual Studio XL, Visual Studio itself, and which you can use. There's unlicensed the browser. There's the extensions for Atom. So just take your pick, and so using the Visual Studio Code, we have created our simple contract test, which is we mainly have we're trying to multiply a value by a given value providing the constructor. We have by using F1 compile construct the contract, we have output the ABI and the by the test.bing, which is then contains the bytecode of the compiled version of the contract. We have it started in test chain, and which you can find in GitHub if you decide to do so. We just run the start batch, which will restore the chain to the default state, but including keeping this specific accounts with enough Ether to be able to do our test. And then we move to Visual Studio, where we have already set up a project which is called Web3 as a dependency, XUnit, as we test them with XUnit. So we have got the sender address that, of our private chain, which it can be found here, and obviously when you start you can use the same and accounts, and you will see it there as well. So okay, so we know the password is password. We have formatted our API, and we have got the bytecode. We have defined our constructor to be 7, and we have next we have then created an instance of Web3 with the default settings, which is HTTP localhost 8545. So if you want to start getting a pointed to a different location or have a different port, you can configure it there. And then we have proceed to unlock our account for 120 seconds, which is a couple of minutes, which is more than enough. Now it's unlocking the account, and it has been verified, and then submitted the transaction. Then we start mining, so our transaction can be deployment can be verified. And now we are gonna wait for the deployment to be mined. Hence we put the while looping here. See, it has not been mined yet, so we are going to wait 5 seconds and see if it's mined. Yeah, now, and it has been mined, so we got our result from this. Now from the receipt we are able to see our contract address, and it has been mined in the block number 1. Now that we have the contract address, we're able to create our contract wrapper and get the multiply function. Finally, we're going to call multiply by 7. So 7 by 7 should return is 49. And let's see, and it is 49. And we're done. Hopefully this has been useful. You can see how you now quickly set up yourself to work with Ethereum using Nethereum itself, Visual Studio Code to write a smart contract together with creating your small private chain. Well, thanks for listening. Goodbye.